once again to this channel. So today I am going to make a video on the spin polarized calculation using our VASP software. So for that, what kind of tags we need to have in our in-car file, that we will see in today's video. So actually I am making this separate video for the spin polarized calculation. In our earlier videos also we have included this kind of tags. Okay, so now let's start. So here I have one in-car file, so I am opening it here. You can see that this is a very simple in-car file where we are simply optimizing a molecule or a crystal lattice system. Here we have taken three like this spin related three such tags, so that we will see from our VASP Wikipedia. So here I am going to search this ISPIN. So here I have searched this ISPIN. So you can see when this ISPIN is equal to 1, then like this is the default value, then the non-spin polarized calculations are performed. So usually by default all the system is non-spin polarized, but if we will write I spin is equal to 2, then our system will become a spin polarized, and that to be in a collinear spin polarization calculation will be performed. And here also some other values are also present, like you can see that by combining ISPIN with MAGMOM, collinear magnetism can be studied. So to study this collinear magnetic behavior, we need to have another tag, that is also we have also used that tag. That one you can see, that is the MAGMOM. And let's see what is MAGMOM. So here I am clicking over the MAGMOM. You see that MAGMOM, this will give the initial magnetic moment for each atom if no magnetization density is present, considered when symmetry is determined. Okay, that means this will provide the initial magnetic moment to each atom that are present in the POSCAR file. Okay, so here if our POSCAR is having such kind, like we have three atoms of any particular like we have three such ions of any particular atom type. Suppose we have carbon and we are having three carbon atom, that means 3 into that value, like n ions or any value you want to give, like whatever present in your POSCAR, and then you will define your magnetic moment. So here it is little bit difficult to understand, but here I can show you that what I have written here. So here you can see this 4 is nothing but the number of atom present for the particular type. Okay, before that I can also show you the POSCAR. You see we are having this POSCAR which has this Fe, carbon and nitrogen. You can see that we have the same Fe atom, but we have written it differently, like Fe and Fe, like this 4 Fe is belonging to one group and this 4 Fe is belonging to another group. So according to that we have defined our magnetic moment, that I will tell you later. So as per this POSCAR we have written our in-car like this, like 4 into this magnetic moment value, then 4 into another value, then 24 and 24 respectively for the carbon and nitrogen. As they are non-magnetic, we have not defined any magnetic moment for that, so we have written 0.00. Okay, next you can also read that what this magnetic MAGMOM value can be given, like when restarting a magnetic moment calculation, MAGMOM is only used to determine the symmetry. So you can read all these, like what this MAGMOM is further doing in the system. Okay, so with this much understanding, we will now understand a little bit better in the sense, here you can see that this 4 into 0.5 and this 4 into 5.0 is giving, like we have two different magnetic moment values, like one is very less, that is 0.5, and one is very high, that is 5.0. So this is suggesting that this MAGMOM will also suggest that which atom is in high spin and which atom is in low spin. So depending on the magnetic moment value, this first Fe group, like first Fe atom in our POSCAR, like this first 4 Fe is in the like lower magnetic like in the high low spin state. Okay, and based on this 5.0 value we can say the next 4 Fe atom are in the like in the high spin state. Okay, so this way one can also define the spin states like high or low spin state. We can also assign the values to we can also assign this to different atom by setting this MAGMOM values. Okay, next L orbit you can, no, not this. So L orbit I can search over here. So what that value will do, that I will show here. So this L orbit selects a projection method onto the local quantum number L and M and write it in the POSCAR or PROGOUT. So if you want to have your projection like quantum number like L and M, then you can have this kind of values for L orbit like 0 1 2 5 10 11 12 13 14. So here I have taken 11 so that I can write this L and M independently in the POSCAR file. So you can also read this like various numbers like how we are choosing all those, and that is also given over here. And if you also want to see some other examples, those who have used this kind of tag, you can click over here example that uses this tag. Then you can find any such example and you can see that in which purpose they have used this L orbit. You see here L orbit has been used but that is not included in this spin polarized calculation. Rather only these two values we can consider. One is the ISPIN and another is the MAGMOM. Okay, so so based on this we can do some spin polarized calculation, and we can also assign the different spin states to a particular atom. And also another important thing I want to tell you here, that here I have written Fe and Fe separately, like two such groups of Fe I have written. So similarly in the POSCAR also we need to include Fe twice, so that it will follow the sequence Fe, Fe, C and N. So not only once we have to write Fe again also in the POSCAR file. Otherwise if you will write Fe once, then like if you will include Fe POSCAR once in the POSCAR file, then it will also return one error to you. So you can consider this, and I hope you have understood, and thank you all, and bye bye.